All right, ladies and gentlemen. Um, so we're going to touch on something that I think is honestly a little bit boring, but absolutely critical to you being able to program well. We're going to talk about data types. And I had a really hard time with this when I was learning to program because I felt like it was just so random. And the way it was explained to me, and I like this, is that you want to choose the best tool for the job. So choose the best tool for the job. And the problem is that computers aren't very smart. So if I just say m equals 34, and say this represents the height of a line or the position of a point, the computer doesn't really know what you're talking about. The computer has to assign memory for everything, and it needs to assign the right amount of memory. And you don't want to assign too much because you want your frame rate to be as high as as high as possible, depending on the project. So you need to keep track of the size of your variables very, very, very closely. And the smaller the size, the better. So for instance, this would be an integer. And you can see over here on our list, there's booleans, bytes, characters, colors, doubles, floats, integers, and longs. These are the primitive data types. Integer is the one that I think is the most common, and it's it's what you know as an integer, right? A whole number, positive or negative. Um, so we have an integer here. We called D, and this one's called M. We're not going to use M, but we're going to go with D. And what we can do with an integer is, move it up and down by ones. You can't move it up and down by halves, but you can move it up and down by one. And so what we can do here is say, let's start with an integer D. We've declared it here. So we said, all right, computer, make a shoebox, write a big D on it in Sharpie, and make it big enough to hold an integer and nothing else. Then let's set up our program. Let's create a gray background. Let's make a reasonably large window. And then we're actually going to smooth things out. I'm going to get rid of that at first, and I'll show you what smooth does later. And then we're going to draw. And the draw function, remember, is a special function that repeats with the frame rate, so you can actually draw your animation. And we'll draw our background again. And then we're going to add one to D. And then we're going to draw a line. And that line is going to be located at 0x, but it's going to move down the screen as D gets bigger. That line is also then going to connect with the lower right-hand corner of the screen. So let's take a look and see how that looks. So you can see here it's moving down by ones, and it's a little bit jumpy. We're moving, integer-wise, so we're growing this integer by one each time. What if we wanted it to be a bit, smoother? What if we wanted it to go up only like part of a pixel each time, so it moved more, elegantly? Well, we need to actually use a completely different data type, and we would have to change this to a float. So a float is a decimal number. It could be 34.5. By using a float, you can actually make things smoother. So you can move things by half a pixel or a third of a pixel. And so down here then, we have control over D, D now being a float. We can, instead of making it go up by one, let's make it go up by, I don't know, a quarter. This will make our line move smoother. And this previously wasn't, we couldn't have done this with an integer. It just wouldn't work. In fact, let me show you what that would look like. If we make D an integer and then try to step it up by a quarter, we'll either get an error or the program just won't work right. So it doesn't even know what to do, right? It's stepping up by a quarter, but because D isn't big enough to store the information, this kind of precise information, the program just doesn't even know what to do. And so in processing, it just does nothing. So we have to change this back to a float. You might be unhappy with the jumpiness of this, and so we can actually smooth out the line with the function smooth. Again, if these things are like, where to get the function smooth? Oh my god, what is that? The function smooth is just in this API, and you gotta go check out that stuff. It's just like learning Spanish. There's no way you're just gonna know all the words and know exactly what to do. You're gonna have to go back to the dictionary and just check stuff out and mess around. Again, my goal is for you to play. I don't want you to repeat what I do and then show it to me. Like, that's not cool. I know how to program. Your job is to come up with a series of projects that are sort of worth looking at, that teach you the basic ideas. And I'll help you do that. Again, go click on the Projects tab to get some ideas. But let's take a look and see what this looks like, huh? And we can see that it's a nice smoothed out line, and it's moving. It's not very jumpy. This is we've smoothed it out, and we're using a float. This looks like a nice animation of a line going down a screen. Isn't that just thrilling? There are other variable types that you'll use less. If you needed a giant integer, we would call that a long. And so you could store a large piece of information, something larger than your typical sized integers. If you need a really big floating point number, we call that a double. And you could store something like 34.34567 blah blah blah, and a whole bunch of decimal points. This is, in your TI-83 or your graphing calculator that you use in math class. Whenever it rounds a number, it's because you got bigger than its floating point could handle, and that computer doesn't have very good memory, and so it has a hard time keeping track of doubles. The TI-83s are embarrassing, and I hope that we never use them again, honestly. So anyways, we can create this double here. You don't use those very much, honestly, unless you're doing something that's very, very precise, like a physics simulation on a giant screen or something like that. There are other variable types that I'd like to show you. Most interesting, I think, are the booleans, and these can be true or false. Usually these represent flags to tell if something has happened, and you can just say true. So you can just kind of say, well, did this happen or did this not? And you could change flag to equal false as well later. The big idea here, though, that I really need you to learn is that when you first use a variable, you've got to declare it. Okay, so we're going to use this variable d. You got to tell the computer what it's going to be. Later on, then, you can just use d willy-nilly, but you got to remember what you created it as. And the final idea, if you want to go back down, so let's say you have a floating point number, and you'd like to change it back to an integer, you can do something called casting. So right here, what we could do is say, let's create an integer called, let's say, integer z, and say we don't want any of these quarter values to happen. We could say z equals the casting of d as an integer, and we can put this here. So what we're doing by this code here with casting is taking a variable that has more precision, that knows more, and we're dumbing it down. We're rounding it down to z. And so this is going to get rounded. So for a while it's going to round down to 0, then it's going to round up to 1. This is really valuable in cases when you use random numbers, and I'll show you that in a second. What does that do to our program? It does something silly here. I'm not sure exactly what's wrong there. What's it asking for? We'll just get rid of that line because we don't need it. Okay, so here goes our line, and you can see it's back to being sort of jumpy and going up by ones because we're casting this as an integer. All right, fantastic. You can see there are some other variable types here. Feel free to play around with those. We'll talk about the composite array types, like arrays and strings and things like that later. But this is sort of the basics of working with a variable. The only thing I need you to remember is that you have to declare a variable before you use it. You could also define it at the same time by putting a definition here with an equal sign. But you can declare it, and then you can use it. You can't just use d. In fact, if I try to go down here and say, oh, use variable k. Well, if we look, variable k doesn't exist anywhere. What you're going to see is that the computer barfs. It says there's nothing named k. You never allocated memory for that. So we have no idea what you're talking about. Let's go back to z. All right, folks, so that's your sort of basic introduction to variables there. All right, we'll see you at office hours.